Well, here we are. Let's work on day 2 of section 2.2 and more basic differentiation. A lot of power rules will be used. That'll be the biggest thing. One thing I want to mention, the constant multiple rule joins with the power rule. And this one we use over and over again, where I have some c, some coefficient in front of the variable x, and x is raised to some power n. The derivative for that sort of function turns out to be I multiply the coefficient by the power n, and then of course I reduce the power by 1. So on this first one, I'm looking at problem 39 here. There really is no reason to rewrite. Everything's looking really nice. This does not have the denominator. It's been moved, right? It's showing x to the negative 2. So let's just go ahead and differentiate this. I'm going to call it f prime of x. So I'll just pretend this was a function f. Okay, so the derivative of the first term will be 2x. The derivative of the middle is just a constant. The derivative of a constant is 0 minus 3 times negative 2 coming down, x to the negative 2 minus 1, using that power rule. So negative 2 comes down, multiplies, and then I have to remember to reduce the power by 1. To simplify this function, it will look like 2x. Negative times negative makes positive 6. Minus 2 minus 1 makes negative 3, so this will be over x to the third. For 46, it would be nice if we had a a product rule for differentiating, because I have two things multiplied, right? So I've got the product of two things, but yet we don't have that sort of rule yet. And soon we will, but right now we can get around it if we simply do the distributive step. So let's just distribute that 3x through, and that'll turn it into a polynomial. And then we can take the derivative of each term. Okay? So I'm going to get y equals 18x squared minus, now take 3x times the 5x squared, and that's going to give me minus 15x to the third. That should be a great place to take a derivative. Y prime equals. The 2 comes down and multiplies, so I'm going to get 18 times 2. X to the 2 minus 1, reduce it by a power. Minus, move on to this function, and the 3 is going to come down and multiply, so I'm going to have 15 times that 3, x to the 3 minus 1. Simplifying, y prime equals 36x minus 45x squared. There's our answer. 51, I think I want to rewrite some of that, especially the square root. So let's rewrite this function. Y equals 6x to the 1/2 power plus 5 cosine of x. To take the derivative, we're going to use the power rule on the first term. Of course, this half comes down, multiplies, so I'm going to have 6 times the 1/2, x to the 1/2 minus 1, plus derivative of cosine will be 5 times negative sine x. And now let's rewrite and make it look pretty. Half of 6 is 3. 1/2 minus 1 is negative 1/2. That's going to drop it to the bottom. I could write it as the square root of x, or I could write x to the 1/2 power on the bottom, whichever way you want to see it. And then minus 5 sine of x. A little more difficult. How would you do this problem? Well, it looks complicated. What I notice is I have a rational function, and everything has an x squared underneath it. Well, I could rewrite this as x to the 4th minus 5x cubed plus x squared plus 7, all multiplied by x to the negative 2 by bringing this up to the top. Then my next step I would choose to do is to distribute this to all four terms. What we're doing is avoiding the quotients from the original problem. So this is going to look like f of x equals x to the fourth times x to the 2 makes x to the second. Remember, we add those exponents. So a 3 plus a negative 2 makes a 1. X squared times x to the negative 2. If I add those exponents, I'm going to get x to the 0 power. And then plus 7x to the negative 2. X to the 0 could be replaced with 1. And now we should be ready to take our derivative, f prime of x. Power rule. 2 comes down, and I change the power by reducing it by 1. I get 2x to the first. Really no reason to write the power of 1. On the next one, the 1 will come down and multiply, right? We're using power rule. So we'll get negative 5 x to the 1 minus 1. But 1 minus 1 is 0, isn't it? We'll clean that up in a minute. Plus derivative of a constant. The constant 1 would be 0. Plus 7 times negative 2 x to the negative 2 minus 1 using the power rule. Let's clean this up. I have 2x minus 5 because x to the 0 is really just a 1, so I end up with 5 times 1, which is 5. Well, 0, 0, so I don't need that. 7 times 2 would be negative 14. This will make a negative 3, so it's going to be over x cubed. Very good. Left with this final problem here, and I'm going to bring that problem just down a little bit so it's easier for me to work with. Well, I've got two things multiplied and I don't have a product rule yet. So we could get this into a polynomial if we multiplied the two binomials together. So let's take and do 3 times that. We're really doing the foiling. 6x squared, the first times the first. The first times the last there, which would be the outers, minus 15x. Moving on to the middle term, I'd have negative 7 times 2x will give me negative 14x. And then last times last gives me positive 35. It looks like we can bring our middle terms together. I'm going to get y equals 6x squared minus 29x plus 35. Ready to do derivative? It's sitting in a nice polynomial, and that makes taking derivatives easier. So 6 times 2 is 12, x to the first, because I reduced by a power. 1 is my exponent, so I get 1 times 29, and then I'd have x to the 0, which will go away. It doesn't really go away, but what it does is it forms 1, so I get 29 times 1, which will be 29. And the derivative of a constant would be 0, so derivative of 35 is 0. Y prime equals 12x minus 29. Oh, there's just so many problems. I think this is our last to set, and then you can work on the homework. So how would I handle this messy function here of f of x? Well, the first thing I'm going to do is, the 4 has to stay down. That's the troubling spot. I could write this as 1/4 x cubed plus x to the negative 2 over x to the negative 5th. But that is like saying 1/4 times x to the 3rd plus x to the negative 2, and let's raise up the bottom and make it x to the positive 5 instead of that negative 5 that was down below. Next step, I'm going to distribute. I still have my 1/4 out front, so let's distribute to each of these terms in the front. X to the 5th times x to the 3rd makes x to the 8th. We'd add exponents. X to the 5th times x to the negative 2 makes x to the positive 3, adding exponents. Now, maybe it would be a good idea, let's take the 1/4, distribute it through, and now let's take our derivative, f prime of x. All of this work here was nothing more than just a lot of algebra to make it look a little bit nicer. If I can get it into a more of a polynomial style, it makes derivative work so much easier. So we're going to bring our power down and multiply, and I think I'll just show it on this one. And then I'll reduce by power by 1, which will bring me to a 7. Same idea here. We're going to bring our 3 down, and I'll have 1/4 times 3. X to the 3 minus 1 is a 2. Little cleanup action. 8 times a 4th gives me 2. X to the 7th. 3 times a 4th is 3/4 x squared. There's our answer. Finally, let's go to this one here. It's sitting in a nice spot. This is our power. It's going to come down and multiply. So we have y prime equals 2/7 times 3/5 x to the 3/5 minus 1. That makes y prime equal. To multiply fractions, we multiply the top times the top, which gives us 6, and the bottom times the bottom, which gives me 35. X to the 3/5 minus 5/5 is what I'm thinking. Or you could do it up here, huh? 3/5 minus 5/5 gives me negative 2/5, which means it belongs in the denominator. Y prime equals 6 over 35 x to the 2/5. And we're done. I think that's enough examples. That following one is going to be very similar to the one we just worked through. So the homework that we're going to be working on is a circuit worksheet. And you're noticing these answers, right? Lots of answers provided. However, this answer is not the answer to this question. It's the answer to another problem somewhere on this worksheet. So for instance, let's go ahead and do this problem. Y prime equals 15x squared minus 8x plus 9. I used the power rule, brought the power down, multiplied it, reduced it by 1. Did the same thing for this term, did the same thing for this term where I had a 1. All right, somewhere on the page we should find this answer, and it was 15x squared minus 8x plus 9. Found my answer. That makes this problem number 2. I'll go through, get the derivative, and then when I find that box that has my answer here, it becomes problem number 3. Eventually, when you're done, your last answer should be this one. So from the last problem of the worksheet, it'll come back to the very beginning, and you've completed the circuit.